Hello and welcome to our first official video from the UAV HUD team. This is Adrian and I will be showing you one of our tests we performed on the 5010 KV340 motor to test the amount of lift it's going to generate alongside our 18-inch propeller. We thought it looked quite fun, so we decided to share it with you. The general setup is a safe filled with weights connected to a motor and our propeller, on top of a scale to measure the weight difference when the propeller spins. Of course, for safety purposes, we ensure the safe weighs around 3 to 4 times the maximum weight the motor and propeller can possibly lift. Also, as an additional safety precaution, we added grip strips to both the scale and the safe surfaces, due to the results of previously failed tests you may check out in the blooper section. Now let's move on to our more technical setup, which is in charge of firstly getting the motor to spin at the right speeds using the ESC. And secondly, we have a wireless connection to the ESC via an ESP8266, which sits on a Node MCU shield. The Node MCU shield is pretty nifty as it provides an extension to the output of the pins. We will power the ESP8266 with a power bank via the USB port. Then a wireless connection will be created via hotspot with a mobile phone for remote control of the ESC, such that we can connect and control the motor strength from a safe distance. We used Arduino to program the ESP8266 to do this, in order to receive and send the PWM controls to the ESC, which then connects to the motor. Our procedure will be to begin our remote connection, configure the motor, and spin it without the blade, just in case the connections between the ESP and the motor are swapped, causing it to spin in the wrong direction, which is far from ideal since it would unscrew the propeller and fling it into the nearby environment. We must make sure it spins anti-clockwise. If it does spin the incorrect way, however, all we would be required to do is swap any two of the connections between the ESC and motor and it will spin the correct way. So now we're establishing a connection to the ESP8266 via wireless. We test this by pinging it once we have used the hotspot to connect wirelessly to the ESP. Then we will use Telnet protocol for sending data to the ESP8266. And as you can see on the screen, we're now connected. Then we send our first command and we'll get a reply from the ESP8266 showing us the validity of our command after communicating with the ESC. Now we go ahead and connect the ESC to the LiPo battery and we'll begin the motor strength test. Well, as you can see, it spun in the incorrect direction and I will show you how to amend that. We now need to swap any two of the connections and that should make the motor spin in the other direction. As here, I just pick up any random one and just swap them. And we give it another go and we'll see which way it spins. We can start with putting the propeller on. The propeller must be spun in the direction shown by the arrow until firm.
So we're going to do a 10% run right now. Of course the pull is very tiny because there's not enough power to overcome the motors. We're going to go 20% now. I have about 200 grams. We will go 30% now.
And so to conclude, the motor was indeed successful at providing the right amount of lift advertised by the manufacturer and passed our strength test. In a future video, we will also test the power consumption of this motor to ensure it's up to spec. Thank you very much for watching, and we hope to see you again soon. Until then, continue tinkering.